This is video 1 for the Psych 642 MANOVA assignment. I'm going to begin this video with a brief description of MANOVA, what it can do, when it should be used, how it works, and what it needs in terms of data and assumptions. So, what can MANOVA do? In the sense that it's in the ANOVA family, it still does the same thing that all ANOVAs do. It tests for differences between groups. The difference, or the thing that's added in for MANOVA compared to ANOVA, is you can test for differences between groups on multiple outcome variables at once. So that's the key thing that is different. Instead of just having the one outcome variable like we do in ANOVA, we have two or more outcome variables. So that also answers the question of when should MANOVA be used. It should be used whenever you have more than one outcome variables that you want to look at the same time. So you want to look at them simultaneously. So you're going to use this test. So in regards to how MANOVA works, it still does the same basic underlying thing as the ANOVA. We're still looking to see how much of the variance can be explained by the predictor variables. So this is still done by looking at the ratio of systematic variance to unsystematic variance. So basically how good your model is compared to how bad your model is. So we're still looking at that same thing. It's just done a little bit differently because now instead of having one outcome variable, we have multiple outcome variables. So instead of a ratio of just one number to another number, we're going to be looking at a ratio of matrices that include the information for the multiple outcome variables. So beyond that point, there's a lot of matrix math involved, which I'm not incredibly familiar with, but like I said, it basically boils down to the same thing as the ANOVA. We're still looking at the ratio of those variances. We're just including more information in a matrix from the different outcome variables. Alright, so this test needs some specific things in order to be used as far as data and assumptions. Some of these we've already talked about. The first is you need at least two continuous outcome variables that you're looking at simultaneously. And then there's also going to need to be at least one categorical predictor variable. In terms of assumptions, it's a lot of the same assumptions as the ANOVA. You still need independence. You still need random sampling or random assignment. We also still want to look at normality. And the assumption, just like for ANOVA, is that the outcome variables are going to be normally distributed within each group. The difference is we're going to be looking at multivariate normality, which means that we assume that the outcome variables collectively as a whole have multivariate normality within each group. And then the final assumption is homogeneity of covariance matrices. So just like in ANOVA, when we're looking at homogeneity of variance, we're going to want the variances in each group to be equal for each outcome variable. But we're also going to want to have the same correlation between the outcome variables in all of the groups. So that wraps up the brief introduction to MANOVA. Now I want to spend a little bit of time talking about the research questions for this assignment. For this assignment, we have to run 2 different MANOVAs. I'll be looking at 2 different research questions that are related. The first research question will be whether or not there is an effect of the type of degree that someone has on perceived competence in counseling bisexual clients and actual competence in counseling bisexual clients. The second question that I'll be looking at is whether or not the degree that someone has an effect on their perceived competence in counseling bisexual clients and their perceived multicultural competence. So in order to answer these questions and investigate these effects, I am going to use the MANOVA for both, and it's appropriate because I have the one categorical predictor variable that has multiple levels, and that being the degree that someone earns. I'll specifically be looking at master's degree in mental health counseling, doctorate degree in counseling psychology, and doctorate degree in clinical psychology for my 3 levels. Then I also have in both cases 2 continuous outcome variables. So in the first study, it'll be perceived competence with bisexual clients and actual competence with bisexual clients. And then in the second study, it'll be perceived multicultural competence and perceived competence in working with bisexual clients. So now let's take a look at the data for these 2 studies. So you can see that I have the degree here, like I mentioned before, the counseling psych doctorate, the clinical psych doctorate, and the mental health counseling master's. And then I have the scores for perceived competence in working with bisexual clients and the scores for actual competence in working with bisexual clients. And then for the second study, once again, degree being the predictive variable with 3 levels, and then perceived competence in working with bisexual client scores and perceived multicultural competence scores. So one other aspect of the assignment is that in one of these studies, the 2 continuous outcome variables needed to be correlated between 0.7 to 0.9. And in the other, it needed to be correlated between negative 0.2 and 0.2. So I'm going to do a correlation really quickly in Excel just to show that this data meets those course requirements for this assignment. Alright, so from the output here, you can see that this is going to be the study where the correlation falls between negative 0.2 and positive 0.2, and then for the next one, you can see that this is going to be the study where the correlation falls between 0.7 and 0.9. So just to reiterate that again, the study where we're looking at the perceived competence in working with bisexual clients and perceived multicultural competence as the outcome variables is the 0.7 to 0.9 correlation. And then the study where we're looking at perceived competence in working with bisexuals and actual competence in working with bisexuals is going to be the study that meets the requirements for the negative 0.2 to positive 0.2 correlation. Alright, so now that all of the information for the assignment has been set up as far as the data goes, I'm going to go into R and import both of these data sets. Alright, so now we can see here that both of those have been imported, and we can see the data in this window right here. I'm also going to open my script file and take the first step of using the library function to load the packages that contain the functions that I need to carry out the analysis. So I'm going to load the ggplot2 package, which has all the graphing functions in it. I'm going to load the mass package, which has the discriminant function analysis functions in it. The MV norm test package, which allows, which has the functions to test for multivariate normality. The past ECS package, which has all the functions for descriptive statistics, and then the reshape2 package, which has the functions for reshaping the data. So I'm going to go ahead and run all of those. So now they are all loaded. Next, I'm going to attach the first data set so that we can start with the analysis by using the attach function. So I'm going to run that. And then I'm also going to use the factor function to set the different levels as well as give them labels. So you can see here, this is what's in the data set as the levels, and then I'm wanting to change the labels to be a little bit cleaner than the clunky initial labels. So I'm going to use the factor function to do that, and just factor that. We can see that we've seen the changes with the factor here.